All right, hello everybody. You can all see this, I hope. Behind me, presentation. My name is Chris. I'm the, I don't need to turn on the microphone, right? That's gonna get me through here, okay. I'm the publisher of Torontoverse.com. You guys might have seen the website. We launched, I think, last September. And we've been sort of steadily publishing ever since then. I'll leave it on this slide. This is cool. We had this custom art done for TorontoBot a long time. It's by a real artist, not an AI artist. Not that I necessarily against that, but it is real art. And if you want to follow along with the slides, they are here. There's like some code snippets here and there. So if you want to take a look at them, maybe I'll just drop them into the chat as well, if I can find the chat. I can't find it. Oh well. Anyway, I want to start, I guess, by saying thank you, all of you guys, for coming out. Thank you to the whole group, Luke and all the organizers, Gabe, everybody who put it together, and Alex. I did not keep track of everybody, but thank you. And thank you to TMU for having us here. This is a great space for this kind of presentation. I'm going to start by talking a little bit about what TorontoBot is. It's a project that we built at Torontoverse. But what I also want to do is really use it as a case study to try to inspire all of you guys. Like, I look at us in this room as, like, you know, the good ones, right? We're trying to do good things with technology, make places better to live, make life better for our fellow citizens. And I really want to inspire all of you to be able to use these technologies to make that happen. Listening to the introductions, I get a feeling that probably there's some experience with AI software development here in the room. Feel free to contribute. I do a lot of this, but you know, I've only been doing it for like 8 months or so. If you've been doing it for a lot longer than me, feel free to pipe up and add. That's what we're all here for. But yeah, I'm really going to talk about TorontoBot as a case study for how to use AI to build better civic technology. So I really want to make sure that's. Next slide. There we go. So it's me, Torontoverse, a little bit about it. We're like an experiment in rebuilding local media on top of open data, right? On the fabric of open data. Can we then bring, written content, video content, audio content, and place it on top of these sort of like, pieces of context and information that are being collected and organized for us? Like, can we break the old broadsheet model for local newspapers and create something totally new and interactive? And TorontoBot was sort of an experiment in doing that, right? Well, okay, can we use technology to make this data a lot more accessible to people? That's really what it is. Has anybody here seen TorontoBot before? Is this new? Anybody? Okay, cool. It's basically right now available in our Discord. You can go in, you can ask questions, literally just ask questions. And what it'll do, what this next slide is about, it will get GPT 3.5 to turn that into a SQL query. It will execute that against a database. We've got a whole bunch of open data stored. Originally, we had just the operating budget for the city of Toronto, but as of last night, I added a 311 service request. So we can actually do two data sets. And the big thing here is we can actually increase this, like, to basically the entire catalog, everything we can get in there, because once you've got sort of table selection working, it all kind of comes together pretty well. But this is generally the idea here. You basically can type a question in. So when I run TorontoBot, I can run it like on my command line. If you have an OpenAI key, you can just grab the data and run it on the command line. You're able to just ask a question. So here I just type in, what were the top 5 programs by total expenses minus total revenue? This works really well. And I love this because it actually turns out that in the last 10 years, we spent more on the police than anything else in Toronto, which I didn't realize. That's like the #1 civic expense in the last 10 years in the operating budget. It's pretty impressive. I mean, impressive. Because the TTC, we spend a lot on it, but it also brings in a lot of revenue, so it really offsets the total expense. The way that this works is I've taken, like, a lot of this data is available as open data, right? It's available in, I think the operating budget is in an Excel spreadsheet. So you're able to just pull that in on a regular basis, just sort through it and load it all into a database, right? I'm using SQLite because I'm lazy, it's really easy to use. And we put all the data in there, and then you can just query it. It's really simple. The hard part, like, I've been writing SQL queries for like 20 years now. The hard part is using the brain power to figure out how to take the question, like the thing you want to know, and turn it into like a query, right? That'll get your data back out of the database. It's hard work, and it turns out that AI is really, really good at it. It's a very well-structured problem. And so what we will do here is talk through how we do that with TorontoBot. We'll show off some examples right now, but we'll talk through how we do that with TorontoBot, the tools that we use. And hopefully you'll see they're so simple and so straightforward. Like anyone in this room could build something using these exact tools. Okay, this is what it looks like. By the way, we also put a charting engine, kind of small here, so it's meant to display like in Discord, but you can also generate charts from the data. That's easy. That's just a little extra. You can use TorontoBot on Discord. This is a Discord link. You can also see the codes on Geomodulus is like the corporate name behind Torontoverse. That's the company. But you can get the code. It's right there at TorontoBot. It's mostly written in Go. I like to write Go. I worked at Google for many years. I learned Go, like getting code reviews from the core team. That's just the language I'm most comfortable in. But I don't think it's the best language for AI. Python is probably the best language for writing AI. Before we get started, are there any questions just on the very high level stuff? And maybe I'll go next, just a quick demo of TorontoBot. New share. Show you how it works. This is our Discord server. Oh, there it is. You guys see it's a little small. Hopefully it's okay. So here we can ask a question. Just use a / command. TorontoBot. Let's say, what was the popular service request type in 2019? Let's see what we can do. I said, what was the most popular service request type in 2019? Potholes. That was the biggest problem in 2019. There were 18,301 requests for pothole repair. So this is basically how it works. I'm not going to generate a chart. That's just one thing. But you can imagine if you have like a bunch of years, you can generate a chart. It can do pie charts and bar charts. I'm currently teaching it stacked bar charts. They're tricky, so I haven't got that working yet. Yeah, okay, great. So back to the original presentation. But what's cool is the tools that we use to do this. So TorontoBot is built using large language models, specifically GPT 3.5, just because GPT-4 is too expensive. In Canada, we actually don't have a ton of choice, believe it or not. Like a lot of the other models are just like not available in Canada, whether that's Claude 2 or Bard. These are not available in Canada, so we're stuck with a relatively small set. I've used GPT from OpenAI quite a bit, and I've also used some of the Cohere models. I do find the OpenAI models easier to work with, but if there's anybody here from Cohere, I do want to be able to get the Cohere models working, so I'd love some help. We use the LLMs in two ways. There's two techniques that we do here. The first one, it's got the most complicated name, but I think it's actually simpler. That's text embedding and vector search. Does anybody know what I mean when I say that? Okay, so people know what I'm talking about. Good. I'm going to go through that in detail because it's super powerful and kind of magical, I think. And the second part kind of blows my mind, but the second part, okay, is function calling with chat completion. So this is basically getting ChatGPT to call functions in your code for you. And this is really where the power of TorontoBot comes from. We're basically able to get really structured output out of the LLM. It's in SQL queries that we can then execute, and we're able to do that in a very reliable way using this function calling. Together, these two features, this is what 90% of all of the consumer AI technology you're encountering today is built with. So if you're using like Shopify, Product Chat, or something like that, and you're using their AI chat, it's built with these two tools, basically, right? It's essentially these two pieces. Okay. Any questions before we keep going? This is sort of like the start of the heavy stuff here. This is a technology meetup, so I'm going to try to go a little bit heavy on the tech if I can, but I will explain everything. I don't have that many slides. The first thing I want to talk about is text embedding and vector search. You'll probably hear this a lot, embeddings, or I got some embeddings for this, or I generated some embeddings. These things are really popular. Vector databases for storing these embeddings are super popular. These are kind of like the heart of a lot of AI search today. I want to walk through what the process is. So large language models are essentially just a whole bunch of numbers, right? They're basically numbers that represent tokens with statistical weights associated with them. I'm glossing over a lot of details, but they're just a bunch of numbers here. And so what I want to walk through here, so we're going to take City Hall, right? And we're going to turn City Hall into a text embedding. This is actual data for City Hall. This is not made up. This is the real data for this using OpenAI. What we're basically, the first thing we do here is we take City Hall and we tokenize it. This is actually how OpenAI tokenizes the word City Hall. What that means is it just breaks the words up into collections of 1 to 3 letters. Essentially, as you can see here, it's group city, space H, all together in different tokens. Each of these has a number. That's the number for the tokens there. So that's actually how the City Hall looks to GPT. And if you get an embedding for that, it basically takes these numbers, looks at the large language model that you're dealing with. There's a few different ones you can use for text embeddings, but it looks at the weights for those tokens relative to each other, and it gives you a big long string of 32-bit point numbers, like decimals. It's like, I think 1,500 numbers. No matter what you put in, it comes out 1,500 numbers back for you. And that is an embedding. It's a bit heavy. I mean, it's a bit mathematical. but we call a list of numbers a vector a lot of the time, right? You can imagine these things in like geometry, right? On a Cartesian plane, you plotted all these numbers together, they make an arrow potentially, right? They've got a start and an end. You could follow that direction. That's really important because what the LLMs let us do, and this is super, it blows my mind when I think about it, they let us work with text as math, right? They let us use math to manipulate text. Super powerful. Still, I'm surprised when it works. The way they do that is basically by looking at these vectors. I'm going to gloss over a little bit of the math here, right? But we're basically going to try to figure out whether or not these two vectors, if you can imagine, this is like a big, we plotted these things in a big graph somehow. We want to figure out which of these vectors are close together, right? In this space. And if they're close together, that's going to be a result for our search. And I think actually for us, close together generally means cosine similarity, which means they point in the same direction. The vectors do. They point in roughly the same direction. I'm going to stand. This is a really simple concept. It's complicated, but it's simple, right? It's just basic math. It's just like linear algebra. It's really simple stuff. But the next slide's cool. It's incredibly powerful. This is the standard embedding presentation. If you had every dictionary, an embedding a database with all of the words of the dictionary embedded in it, right? And you were to type this word, king minus man plus woman, and you were to get the embedding for that. King minus man plus woman, and do a search on the database, you will get back queen as the word that most closely matches. Right? Even though it's just math, right? You're just looking at vectors and comparing them, because those vectors are weighted with like all of the statistical weights of everything that anybody's ever written ever. It's able to see these relationships, right, between different words. And so a lot of times you'll hear people say, we've built AI recommendations, or we built AI product search, or we built like AI clustering. And pretty much all of these various tools break down to basically like this embedding in vector search. And so you take your pieces of text, right? You turn them into vectors. You put them all in we use database space or a vector index, right? You put them all in an index, and the index just exists to answer the question, here's my query vector, which are the closest vectors to this one in the database? This feels like it should be complicated, but it's actually really straightforward. And actually the tools for doing this, the vector databases, they're like exploding. They've got a ton of VC money right now. I think the most popular one is probably Pinecone. There's another one called Weaviate. These are basically, Weaviate's free to use. Pinecone is weirdly expensive to do anything nice with it. But there's also like, in my case, I use a vector database that we spin up on the machine itself. It's not something that's just an open source thing. So by just using math, you're able to do like meaningful manipulation of text, which I feel is just a super powerful concept. What do we use it for? Well, the hard part for us is we've got, we want to be able to have hundreds of tables of data, right? We make accessible to people, and a question comes in. The hard part becomes, what table should we route this question to? We'll talk about doing questions across tables eventually. I really want to be able to do that, but right now the question is, where do we route this query? And what's cool is we're able to do it with text embedding and vector search. So I have a description of every database table that we have, right? So it's the schema for the table, all the stuff that's in the table. If there's like a set of enumerations, like the programs in the budget, for instance, right? There's, 70 of them, 60 of them, something like that. We list them all out so that they're all available to the bot to look at. And then we basically encode all that into an embedding. And then when the query comes in, right? If you want to ask the question, like when I asked earlier, what was the number one service request? The first thing that's going to do is take my query. It's going to turn that into an embedding the same way it did, with all of the database descriptions, the table descriptions. And then it's going to query the database for what's the closest database vector to the one that you just put in as a query. And then it's going to run the actual SQL query against that table. Is that landing? Does that make sense? It's kind of magical to me to see this happening. I know a lot of engineers here, it probably makes sense to them, but the fact that you're able to use this, right, these models that have trained on language in order to give mathematical weights to the text you're working with, and then you use it for something, it's pretty powerful. Yeah. So next, I have a better example here. Function calling. Oh, yes.
Do you have one question? Why allow the decision making to these operates rather than you end up getting database with all
these things? Yeah, basically we wanted to be able to query a lot. I think I didn't think about doing it with raw text. No, I thought about putting it into a database query, in part because I was inspired by a project that already existed. I should mention it here. There's one in the US called Text SQL, where a bunch of guys started doing this with census data in the United States. And my original queries, when we started this back in April, we sort of started with what they had and said, let's do a Toronto version of this with Toronto data. A lot of what we do is, basically collecting, hundreds or thousands of line items or the original queries in the operating budget database. And I think it would have been very difficult to get the LLMs to do the calculations on that reliably. I think there's a lot of open data that's naturally textual. I think we can get our hands on that. Like think about like city council minutes or something like that. To me, this is the perfect case for, like, if I could get my hands on Claude 2 and I could get like 100,000 token window, you could do some pretty incredible stuff with like city council minutes and things like that. So I would love to be able to get in there. But I think for now, the more achievable stuff is stuff where you're asking for really structured output from the LLM. And I think that's stuff that we've been able to get working with a high degree of reliability. And these SQL statements are really, obviously, they're very, very structured and very easy to get reliable output. But I would love to be able to do that. I think city council minutes, I think, are the best example. Like, can you have a conversation about what happened at city council with a chatbot? I think that would be pretty cool.
Have you seen barriers to generation for the model fails, like the data format is
So for a long time, as you probably know, a lot of the original function calling was done like we hand rolled our function calling. It was basically like you would beg the LLM to give you JSON output, and then you could work with that if you got it out. We used to see failures when that it would occasionally just not generate the right output for us. But since proper function, we're going to get into this now. Since proper function calling was added to the OpenAI APIs, I haven't had any problems at all. It worked completely. So we would have hard problems, like it would output JSON, and then it would put like new lines in the SQL query. Okay, I can do JSON5. There's things we can do to work around it, but these little edge cases that would sort of surprise you with all the time. And now with function calling, it doesn't do that. So, yeah. So I sort of alluded to this just in answering the question, but function calling, this is another area where I think it's really impressive to work with AI. This is basically where you can give it a bunch of ambiguous input. You can give it some really well-structured format for the output, and it will sort through your ambiguous input and properly format the output for you. That sounds minor, but there's a huge amount of what you do interacting with computers every day that basically boils down to just trying to take like this ambiguous stuff that's in your head and fit it into the computer one way or another. Have you ever had a job that involved filling out a form and hitting enter, like data entry? A lot of what you're doing is basically just, you've got this rigid form and maybe you've got somebody's like filled out with like a sheet of paper or something. You're trying to deal with that sort of like all the edge cases that come with like a handwritten form and getting it into an actual computer. That's the kind of thing that function calling in AI in general can do a better job than you can. Like, it doesn't get tired, it doesn't get bored, it doesn't miss things in the same way that you do. You can tell it not to be creative, you can tell it to be boring and do everything just right. And what's great about that is it's really powerful at cutting through complexity, right? So if you have something like the City of Toronto's operating budget, there's a lot of stuff in that operating budget, and learning how to properly figure out what's going on in there is like, it's a skill and a challenge in and of itself. When I started building this, we worked with one of our freelance writers who works a lot with us, named Matt Elliott, who runs a blog called City Hall Watcher. I'm sure he's been to one of these before. Of course he has, right? Yeah. And he'd spent a lot of time himself personally working on this budget analysis stuff, right? Trying to figure out how to write these queries. And at the end of the day, he ended up importing the whole thing extremely carefully into like Microsoft Excel so that he could write Excel queries against it. So just easier to figure out what was going into the database that way. But it was extremely tedious and hard for him to do. What we're able to do here is basically, 100x the speed that he's writing queries and looking into the database. If you're like us, right, you're Torontoverse, and what you want is to be able to find new things to write about, right? To be able to find interesting stuff out there that you can tell the people in Toronto about, being able to do 100 times the search base through the database to look for interesting stuff. That's really powerful. And I think that hopefully is what I think Matt did a write-up on TorontoBot for us when we first did it. And I think that was the message he tried to get across in the write-up. So, in getting into the specifics of it, function calling was actually developed with like pure text LLMs. Like I started using this back in March when we would just basically get straight text back from GPT-4. Like I said, you would have to beg the LLM, like the chat, to give you back a JSON response. Sometimes it put a little text at the top and you couldn't parse it correctly, it would work. Other times it would give you the text directly. But people had a lot of luck with this. I had a lot of luck with this. Our internal at Torontoverse, our CMS, is actually a Slack bot. So we just basically like paste in the contents of a Google Doc that a writer will give us, and it handles sort of like breaking apart the headline and the byline and the category listing, the publication date, and wrapping all of the text in HTML tags and all that. We did all that basically just with this really basic system of begging the LLM to give us JSON output in response, and parsing it and then handling retries when it inevitably got it wrong every so often. In June, they basically formalized this feature. If you ever use ChatGPT plugins, it's the exact same thing that powers the plugins. I actually don't like them that much, but I know people do love them, especially the code interpreter. And it's the same thing behind that. It works extremely well. Like, I will show you an example of what a function definition looks like. But if you can go out of your way to really carefully define the parameters of your function, the LLM will be able to understand them. Like, I've got GPT-3 working completely reliably with these SQL queries. GPT-4 is like an order of magnitude smarter than GPT-3. It's just too expensive. Like, I might, if we were to do TorontoBot with GPT-4, it might cost us $1.50 for a query or something like that. Whereas it'll cost us something like 2 cents or 3 cents for GPT-3. So the prices are just so different. But if you're doing something important, right? If you're doing something business critical, if you're making money, or if it's part of like something that's really core to your business, $1.50 is not a big deal. It's a lot cheaper than trying to pay somebody for their time to do it, especially because what you're really getting from GPT is just this ability to avoid boredom, to sort through complexity, right? To do all of that. So what do these functions look like? Basically, this is really, sorry, it's kind of small. This is the whole function though, so it helps to see it all. This is really cool. I learned about this. Programmers say here, it says JSON schema. Has anyone learned this before? JSON schema. I learned about this for these function definitions, but it's basically a way to describe a JavaScript object in JavaScript in like JSON notation. So you basically describe very carefully what's going to be in the object. So here, the name of my function is SQL analysis. That's the name of the function. And the description is it accepts SQL analysis derived from user queries. It's basically just telling the LLM what this thing is supposed to do. So there's another system prompt that tells it you should come up with, and I'll show you that in a second, that tells you should come up with the SQL query. Here's the user prompt and all that. But basically, this is how we collect the output. And so the parameters are parameters and object. It's got 3 properties. One is the schema. So that is basically a comment on what parts of the schema the TorontoBot thinks are relevant. It's doing this so that you can second guess it, right? And look at why, like it's expressing the reasoning it used to come up with the query. It's 2 reasons. One is so that you can see why. The other reason that when you ask it to tell it what it's about to do, it self-prompts itself. Just sort of like, you guys know how these LLMs work, right? They're just auto-completing like one thing after another, just like an unending stream of consciousness with no delete button at all. And so if you ask it, right, to tell you what it's about to do, it's now put like 3 or 4 sentences down describing what it's about to do, and it's now much better prepared to start auto-completing to do the actual task you asked it to do, right? You basically, it's self-prompted itself. So we get it to do this, where basically it's a couple of like sentences about what approach it wants to use. It gives us the actual single-line SQL query to run. Right? These instructions are respected so well. This is where we were having trouble before. There was no way to give it clear instructions to follow. And lastly, I needed to tell it whether the result was currency, so we can figure out whether to put a $sign in front of it. But with just this, right, we basically send plain text to the LLM. And with this definition, by tacking this onto the query, we say, hey, here's one of the functions we have. At the end, it has this ability to respond and say, okay, I want to call the SQL analysis function, and here's my schema comments, here's the SQL query we're going to use, and no, it's not currency. And I'm going to show you what that looks like. Or not, I can't get my screen to respond. Sorry guys, it seems like Tmux doesn't like Zoom. I did test this beforehand. Well, we'll do it here. And so, I'm the new share. All right. And so to tie it all together, let's actually take a look at the let's take a look at the prompt. And that'll sort of be my conversation ender here. Sorry, guys. Easier said than done. It was going to be too long. Maybe I'll do that in a breakout. Sounds good, because I'm just going to have to find my have to find a plan B for it here. All right, I'll do that in a breakout. I'll get into the details of how it works. That's not it. Sorry, guys. Trying to find the new share. Found it. That's not the right window. It just made me stop sharing and resharing. I think I made it full screen and now I can't find it again. Here we go. Are we back? There we go. Okay, so we'll go to the details of the actual prompts in the breakout. But at the end of the day, the reason I'm bringing this to this group of people, right? The reason I want to talk about this here is I'm hoping to inspire a bunch of you, and I want to help. If you're trying to make something with LLMs for the public good, right? If you're trying to use this technology, it gets a bad rap from a lot of people. I think it gets looked at as there's a lot of uncertainty around what AI is going to do to the way that we do things, and it's totally changed the way I make software. Like 4 months ago, I made software completely differently than I do today. But at the end of the day, I think it would be a mistake not to use this technology to make life better, right, in cities for all of us. And I think it's exceedingly easy for us to do that. And with all of the tools that the open data team has given to us, like there's so much that we have to work with. There's so much raw material. It's been really difficult to pour through all this data. There hasn't been like the human energy to pour through all that material. And now we're able to do it and hopefully create some really incredible things for people. You can take a look at Torontoverse.com. We've done a lot of this already. We've got a bunch of data stories of various types that are drawn off of this general strategy. And I think that's we're just scratching the surface of what's possible. I especially think there's a lot of opportunity for using these to help people that can't otherwise parse the complexity of, like, government's got a lot of essential complexity. It's a big thing. It can't turn anything away, right? We have to deal with everything in government. AI can be a really powerful tool for helping regular people cut through that complexity and access these services and deal with this essential complexity in a manageable way, right? And I think that's what I would love to see happen. I think we're racing against a lot of people that would like to maybe use it to make things less accessible or less clear. So I think it's important that us, right, like the X-Men, that we help do things right. So if you do need help, you can join our Discord server. You can email me directly. I'm really passionate about this stuff and seeing it, get used correctly. We do this a lot at Torontoverse. I've got a lot of experience working with these technologies directly, so don't hesitate to ping us. And lastly, I'm going to put a shameless plug in here because Facebook cut us off today. Torontoverse.com, we just launched a newsletter. It's a daily roundup of Toronto news, so feel free to sign up if you're curious. All right, and I'll go into the details in a breakout. I'll talk about exactly how the prompts work, how we get these things to work, and how simple they are to build. You'd be surprised how quickly you can go from zero to really, even if you're not an engineer, go from zero to building something like this. My wife, Umbreen, is a product manager by trade, but she started working on this as well, and she's made some really important contributions to Torontoverse. Sorry, TorontoBot. Torontoverse too, TorontoBot. So I think, the message is that it is really accessible. It's not that hard to do, and GPT-4 is a really good help if you need to get started. All right, thank you.
We're going to do a lot of chat and breakout, but we've got maybe time for one question in the room and one question online. So if you're online, the first person to get a cue in the chat gets to ask now, and then someone in the room with a question. Yeah.
So the question was, you use function calling as a core tenant, but it came to OpenAI only on like June or something like that.
June. Yeah.
You started in March.
So we started using, like there were a bunch of, the research started coming out on how to get AI to do function calling, I think like last September or so, was when we really started to see it sort of appearing. I used some of the agent style prompts originally, worked extremely well for us. I think not nearly as well as what we're getting today at a function calling, but we use those agent style prompts a little bit. I don't know if you've seen the reports like thought, action, you get it to, you do the same thing where it would pre-prompt itself, where it would give you like an output of a thought of what it was thinking about doing, and then it would eventually usually call the function correctly after that, or if you say action, colon, and then it would give us the function output we wanted. We generally couldn't use pure JSON, and once it got complicated, it would screw up the JSON immediately. So we would have to come up with your own way to encode the function parameters into text, which was really frustrating. but it worked. And in the breakout, I'll show off some of the stuff where like much more complicated stuff we're able to do with that pattern internally. But yeah, it worked surprisingly well like that. Once they brought function calling in, that was a night and day. I had to move everything over because it was so reliable, and you could do these big comprehensive functions and get really reliable output for them. So it just became so much more efficient. Things.
We have a question online.
Really?
Henry?
Yeah, that's the way LangChain. Yeah, they're the agent.
Yeah, hi, can you hear me?
Yes.
This is probably a very naive question. Sort of at a philosophical level, where does semantics fit into the LLM structure?
I mean, I guess I would say that the LLMs are trying to create like semantic modeling of the entire English language, right? Semantic, that's how I would look at it. It's like LLMs are trying to understand the meaning behind these tokens through statistical relationships. So, while it doesn't necessarily understand, it does get the semantic meaning of what you're saying. And for GPT-4, even in pretty obscure situations.